Hello, and welcome to Ciena Chalk Talk. My name is Maurice O'Sullivan. I'm a Senior Director of WaveLogic R&D here at Ciena. Today, I'll be describing the benefits of some advanced forward error correction, or FEC, algorithms we are developing for WaveLogic 5 Extreme. Specifically, the benefits of a throughput optimized FEC implementation, a just right FEC. What is throughput? It's the rate of transmission of information. For example, 100 gig and 800 gig, these are throughputs. What is FEC? It's an algorithm, often system vendor specific, that acts to correct errors at detection by processing extra bits coded at the transmitter. These extra coding bits, referred to as FEC overhead, are some fraction of and dependent on the intended payload information bits. The ratio of the payload bits to the total bits sent, including FEC overhead and payload bits, is the FEC rate. Thus, the FEC rate is less than 1 and decreases with increasing FEC overhead. The lower the FEC rate, the greater the overhead, the greater the error correction capacity, the greater the FEC complexity, and the higher the power required to service a given payload. All bits, payload and overhead, are encoded onto symbols. The symbol rate is the baud and determines the spectral occupancy. At fixed symbol rate, the higher the total bit rate, the more crowded the symbol space, the smaller the intersymbol or Euclidean distance, the more errors to be corrected per payload bit. For a fixed throughput and fixed symbol rate, consider varying the FEC rate. As the FEC rate decreases, the error correcting capacity increases, but also the total bit rate must increase, and this increases the number of errors per payload bit. Eventually, the extra errors per payload bit grow faster than the error correction capacity provided by further reduction of the FEC rate. As the FEC rate increases, the total bit rate decreases, and the number of errors per information bit decreases, but also the error correcting capacity of the FEC decreases. Eventually, the decrease in the error correcting capacity of the higher FEC rate is faster than the decrease in the number of errors per information bit from further decreasing the total bit rate. It follows that at a fixed baud, there is a just right choice of FEC rate for each throughput. It turns out that the higher the throughput, the higher the FEC rate, and, consequentially, the lower the FEC power dissipation per payload bit sent. In summary, given a specific baud, more throughput means higher FEC rate at best performance, and this means lower modem power consumption per payload bit sent. WaveLogic 5 Extreme achieves this objective. What does this mean for our customers? Lower power dissipation per modem and higher system performance, for example, higher reach for a given throughput, or higher capacity at a given reach. Throughput optimized FEC is an example of DSP innovation implemented in the WaveLogic 5 Extreme to deliver unrivaled system performance and spectral efficiency across network applications.